Okay, so the second problem I had for Chapter 4 Bingo was 4.7, and the problem is a 68.5 kilogram skater is moving initially at 2.4 meters per second on a rough horizontal sheet of ice and comes to rest uniformly in 3.52 seconds due to friction. What force does the friction exert on the skater? So the first thing that immediately comes to mind when you're looking at this problem is Newton's law that force is equal to mass times acceleration, because what we're looking for is the force that the ice is exerting on the skater. And so we can see that before we can do this problem, we need to find out what the skater's acceleration is, which in this case, since the skater's slowing down, is going to be a negative number. And we'll see that as we come to it. So now we need to think, all right, what equations do we have or that can we use that'll help us find acceleration? So we can just from the equations of kinematics, the first equation that comes to mind is you can find any given velocity or velocity at any time given the initial velocity plus acceleration times time. And so we know from our problem that we're already given the initial velocity of 2.4 meters per second, and we're given our time. So we can just solve everything over to give us our acceleration. So when we do that, we have our velocity minus initial velocity over time is equal to our acceleration. And then we know that our velocity that we're looking for is going to be 0, because that's our ending velocity. That's when she comes to a complete stop. So we know that's going to be a negative 2.4 meters per second over 3.52 seconds is equal to our acceleration. And then when we divide that through, that gives us a negative 0.68 meters per second squared. So now we have an acceleration to tie into this first formula. And we know that the skater's mass from the problem is 68.5 kilograms times a negative 0.68 meters per second squared. And then that gives us a negative 46.7 newtons of frictional force on the skater from the ice.